Hi there, my name's Glenn and I'm preparing videos that are all about Arduino. I've noticed that Arduino are planning to release a few new models in the not too distant future, so I thought I'd have a bit of a review of those. But before we get into those, I thought I'd look at some that have been around for a little while, such as the Arduino Uno WiFi Rev 2, which sounds like an Uno, but it's actually a bit more than that. So I thought I'd have a look at that and have a bit of a deep dive and look at some of the capabilities of it. So stay tuned, and if you can help me out, support my channel, please have a look at my Patreon and or buy me a coffee. Okay, so stay tuned and let's have a look at the Uno WiFi Rev 2. Okay, so here we have an Arduino Uno Wi-Fi Revision 2 direct from the manufacturer, and this is the moment of excitement where we do the unboxing. So obviously there's an Arduino Uno board in there, and it comes in this nice little plastic carrier which I guess just protects the pins from being shorted out, and also protects the surface you're working on from being damaged. So that just clips in there like that, and then there's some information, and probably the most exciting bit is some stickers. Okay, so I'll do a little bit of a side-by-side comparison. Obviously they look similar, but the Uno Wi-Fi is a little bit busier, there's more stuff on it. They both have the same ports, the USB and the power supply. They both have the same digital I/O and analog and power connectors along the side. They both have the same ICSP for if you needed to ever recover the bootloader or just directly load onto the chip. They even have the same 32U4, which is used to control the USB interactions. They are the same, even though the Uno Wi-Fi has a slightly smaller package. It's just a different configuration. A couple of differences though is the ICSP header for the 32U4 is not present on the Wi-Fi, but it is present on the Uno, so you could actually upload a new program to that, but it might be a bit more difficult on this one. But normally you wouldn't want to do that because you just want this one managing the USB for uploading code and the serial output. Apart from the other differences about the busyness of it, the MCU is different. So this particular Uno has a DIP chip, which is the chip that we're programming, the main MCU. This is the AT Mega 328P. This one has a smaller surface mount package, and it's an AT Mega 4809. This here is the Wi-Fi and Bluetooth system. These things look impressive, but they're basically just 5 volt to 3.3 volt converters. There's an IMU, which I think is this one, and there's also a security encryption chip which allows this board to be used with the Arduino Cloud if that's what you want to do. A couple of other differences: this one's a bit of an older MCU. The 4809 is a newer generation. This is a 48 pin. I think this one is a 28 pin or maybe 24 pin. So this one has a lot more digital I/O pins. It also has a lot more built-in hardware, so it's a bit more like a Mega in terms of what it's capable of, but obviously it doesn't have the extra pins down here for all the extra digital I/O. So you're not getting exposed to the full capabilities of this, but then a lot of it is also being used to communicate with the Wi-Fi, Bluetooth and the IMU, and with the encryption chip. Other things, the original Uno, which is a Mega 328P, has a slightly smaller memory. So this one has 32K of program or flash memory, has 2K of RAM and 1K of EEPROM, whereas this one has larger memories except for the EEPROM. This one has 48K of flash memory or program memory, has 6K of RAM, but only 256 bytes of EEPROM. So you typically don't use that much of that anyway, so that's not a major drawback. I think they're the main highlights. We've got an RGB LED which is very bright, I think, which relates to the wireless communications. We've got a power indicator over here. We've got the inbuilt LED and the transmit and receive LEDs as well. So a lot of things are similar, but this one's a much more comprehensive and powerful package. Another thing that is really useful compared to, say, the Mega and the Leonardo, is that this chip, the 4809, is actually available in a DIP package. So it's available in one of these types of chips, which is mounted into a socket. I don't know how easy to see that is, but it's in a socket. And so what that means is you can actually offload a lot of the other stuff that you don't really need when you're wanting to build a project to run inside something. And so an example of that might be this thing which I've built, which just manages some blinking of some LEDs. So you can see there's very little on there at all, other than the ATmega 328P, a few resistors for the LEDs, and a bit of a clock support and a capacitor there for driving the or smoothing the power supply. So that sort of chip is easy to use if you have simple tools like I do, such as a soldering iron and of course fat fingers. Look at my finger compared to that, it's very difficult for me to grip that. But the drawback is, because it's a comprehensive chip, that's the DIP package. That's a 40-pin DIP. This 4809 is actually a 48-pin chip. These DIP packages, the largest they come in is 40, so there's actually 8 pins less on this as compared to that, so you won't have access to everything via this, but there's certainly more than enough there you'll be able to access. And unless you needed the full 48 pins, then there are some capabilities to do what they call multiplexing, which has changed the function of these individual pins on the chip. So you can access some of the functions even if the main or primary pin is missing. Okay, so that's the hardware overview. Let's set this one up and see if we can get it to do something. Okay, once we have the board set up, obviously we need to plug it in. And as we would expect, you can see the built-in LED blinking. It's a little bit hard to see that one on the video, so I have connected up another external LED connected to pin 13, which is where the built-in LED on a standard or older traditional Uno is connected up to, but it seems like in this case it isn't connected to pin 13. So let's have a look at that just briefly as we progress. Okay, so before we get started, you actually need to install some software to make this board work. So what we do is go to Boards Manager and let it do its thing. If you leave the IDE open enough, you might get a little panel down here that looks a little bit like the update libraries, except in this case it's add a new board to support it. You can click on that link and it should take you directly to here, but I've only ever seen that once or twice. So the manual way of doing it is to open the Boards Manager like that, then filter it on Mega AVR. So that filters it to the board that we need. So obviously there's a few versions, we want the latest, so install that, let it do its thing. There is a permissions thing that occurs on Windows, but unfortunately I can't capture that image, so I skipped over that bit where the screen goes blank. But now that's installed, we're ready to go. You may see 2 permissions requests, it depends upon what your system, how your system is currently set up. So now we have the blink program. I can just modify that. Obviously we also need to make some selections in the board menu, so we're not using an Uno anymore. We actually need to go to this new selection here, Arduino Mega AVR boards. The traditional Uno is here in AVR boards, but this is a Mega AVR, so we need to select Uno WiFi Rev 2 like that. And then obviously we need to select the port, which looks like it's COM8. And there's another menu selection here, which if you do any direct hardware register manipulation to manipulate the digital I/O ports, then this provides a software layer that allows that to continue to work despite the fact there's a newer processor. You can disable that hardware emulation by selecting Mega 4809. I may look at that a little bit later if the video doesn't get too long. But generally you wouldn't need to worry about that, just leave it with the default, which is 80 Mega 328. So selected COM8, and so we're ready to upload. We've increased the speed. Okay, so that's finished uploading, and we can see the LED is blinking about the same. Why is that? Okay, so it's finished uploading, and we can see the LED is blinking a little bit faster, but still, as explained before, the external LED, which is easy to see, isn't blinking. So we just fix that. This, by the way, has nothing to do with that registers thing that I was pointed out earlier. It's just that the LED built in on the Uno WiFi Rev 2 is wired up differently to the built-in LED on a traditional Uno. So there's a couple of ways I can do this. I'll just undefine the LED built in, and I've connected it to pin 13. So I reset that to pin 13, re-upload. And now you can see the external LED is blinking, but the internal one is not, which actually further proves that it's not connected to pin 13. But that's how you get the board set up. Let's have a quick look at this menu. Well, remember we mentioned that the Uno Wi-Fi has a Mega 4809 MCU on it. So what this does is allow you to emulate some of the ports that are on the Mega 328 to work the same way as they would if they were on a native Uno, even though you're running on the 4809 board. So how does that work? Well, we'll look at this first. So this is a diff of the compilation. So basically what I've done is I've captured this output here, and I've done it once with the 80 Mega 328 selected and one with the none option selected. And so we can see what that does in here. First of all, it outputs a message. This is a side-by-side comparison. This is the 328 compilation, and this is the 4809 compilation. And this is an incremental compile, so it's the second and subsequent compiles after doing a full compile the first time around, only because it's a little bit briefer. But otherwise you can see the same things. So first of all, there's a message telling you what it's doing. We can see here that this piece of output is different, and the difference is that on the 328 version we have on, and here for the 4809 we have off. So this parameter FQBN simply means fully qualified board name, so it's basically a label, and it's making the distinction of how this compilation has worked. I'm not sure where this name is used, but it does have that effect. It also occurs down here again a second time, so we have mode on and off depending upon which model we've got. But the key difference is this symbol here. So in the if we have the 328 registers selected, then it defines this symbol Uno WiFi Rev 2 328 mode, and if we don't have that on, then which was labelled none, then you can see there's nothing in this part of the compilation process. So this is passed to the C compiler, AVRG++, or the C++ compiler, and we can see that's the true for all instances. So what does this one do? Well, let's have a look. So this file is arduino.h. It's included by default in every Arduino program, and what we'll see here is somewhere if def Uno WiFi Rev 2 328 mode include Uno compat.h. So if that symbol is set, which it is if we choose the 328 register mode, then it'll include this Uno compat. Obviously there's another option for the nano which includes a different file, but we'll only look at this one, Uno compat, because that's the board that we're looking at. So what does that do? Well, it includes this file, Uno compat.h, which is a fairly long file that defines some classes, and there's a whole bunch of definitions in there which I won't go through. But what it does, if you're familiar with direct port I/O, it's defining a software layer for ports B, C and D, and DDR B, C and D as well. Notably not PIN, P-I-N-P, so not this one, C for example, or pin B, not that one. And so if you are not familiar with what these mean, then you probably don't need to worry about it too much. But if you write programs that do direct port manipulation, such as like this line of code, which is actually for a Mega 2560, which is why it's using port A, then what it allows you to do through that software emulation layer is continue to run a program which you wrote for an Uno, which uses the 328p registers, and this type of code for port or DDR will continue to work as expected on the Mega 4809, even though the registers and the hardware connections are different. So that's the effect on the IDE. As you can see, we have the new selection, or the sub-selection, the new boards, and we get this extra option for the registers emulation. And of course, if we have one plugged in, then we can see it, so I'll just select that now. Okay, so now that we've set the board up for use, there's a few libraries that we need to download that are recommended for the WiFi Rev 2. So just look at that real quick and download those. So this is the product page for the Uno WiFi Rev 2. You can see it's a little bit pricey. I think that's the US dollars amount. And then on this page there's a link. It's a little bit hard to find, but down in this compatibility section you can find this link, getting started page for the Uno, and that opens up this page. And so here we can see the setup guide, get started, so you can follow those to see that process we just did to set up the hardware. But the bit that we're looking at now is in this Essentials tab, so you can scroll down to it or just click the tab and it takes you to there, and it shows the the libraries that we need to load. So there's one for the Wi-Fi, one for the Bluetooth, one for the IMU, and then there's some sample programs which use the Wi-Fi for generating MQTT messages. And as you can see there, it's a great tool for Arduinos to lightweight collect data and publish it to the net, and then other applications can subscribe to that and download the data or store the data or whatever you want to do with the data. So we'll install these four. Just move that out of the way. So the way we do that is we go to Tools, Manage Libraries, let it do its thing. For some reason it came up on a different screen. Anyway, let it do its thing, and we can just start typing in the names. So Wi-Fi Nina. Now what we'll find is that there's quite a few matches for that, and it can get a bit confusing. As it turns out, it is the first one. So I scroll back up there, it is there. But as you can see, there are a lot. So one thing we can do to sort of narrow it is to just filter it to the Arduino official ones by clicking that selection. And you can see it's the only one. That doesn't always make it just one, but it does narrow the list. So we just click install, and that's done, almost. So we do the next one, which is Arduino BLE. So there's one, there was a couple of choices, but it looks like this one because it mentions the, there is Arduino WiFi Rev 2. So I'll install that one. Next one is Arduino _LSM 6DS3. And there it is there. So I'll install that one. And then lastly, Arduino MQTT client. No, not close. So install that one. And when we done, just close the dialog. And then what we'll notice is that in the examples there's a bunch of new settings. So there's the MQTT client, there's the IMU, what else? There's the Wi-Fi, so there's some sample programs. And for some reason the Bluetooth appears down here in a different group. I'm not sure why that is, it just is. So there's a few programs there, and we'll start looking at some of those next. Let's have a look at some of the sample programs. I'll start with the MPU. As you'd expect, the examples will be in the examples menu, and in this case the MPU examples from the LSM6DS3. They're both basically the same. One is reading the accelerometer, so we'll use that one. Now, one thing I noticed when I was testing is that there's a problem with this program, that it causes the IDE to have some sort of funny behaviour. I can't close windows, can't upload new versions and things like that. It's easy enough to recover. You just unplug the Arduino and plug it back in again. But I'll address that in advance. There's two ways we can fix that. One is I can put in a delay down here, something like that, which I won't do. Or I can increase the speed, which is what I will do. So I'll change it to 115/200, and then we should be good to go. So I'll just upload that. Open the monitor. As you can see, it prints some data. I just put the Uno up so you can see it. And as I move it around, you'll see that the numbers are changing. That's a little bit hard to follow because it's going so quickly, and it's also pretty meaningless. But the program's set up so we can use the other monitor, the plotter, in fact. So there it is. That's actually the problem that I was exhibiting before. So if I unplug it and then plug it back in again, you note the monitor goes away. So to change it over to work with the plotter, I'll just uncomment all of that. So now all I'm doing is printing out a header and then all of the values, and maybe I will put in a delay, just a short delay because I'm having a higher speed. And I'll upload that again. The other problem you have if it does exhibit the strange behaviour is that the upload part doesn't work. Okay, so that's done. So what I'll do is now open the plotter, and as you can see, we can see three lines, one for the x-axis, one for the Y and one for the Z. So as I move the board around, reposition things so it's visible, that should be good enough. As I move the board around, you can see the graph changing. So up and down, that's the Z-axis, so the green line changes. Side to side, I guess that's X, so the blue one is changing, and then back and forth, that's Y. So the red one is changing. There is actually printed on the board, it's a little bit hard to see, but just here, zoom in. You can see there's a X, Y and Z annotation which illustrates which way those axes are. So Y is that way, and yes, that's affecting the red line, and then X is that way, so it's affecting the blue line, and then of course Z is up and down, so that's affecting the green line. Okay, so that's the MPU example. Okay, so I think let's look at some Wi-Fi examples. So again, these are in the examples menu in the Wi-Fi Nina directory, and we'll start with scan networks because that's probably the easiest one to get going. Set the baud rate. Upload. So it just takes a few seconds to get its data, and there we can see a list of access points. It'll delay for 10 seconds and then it'll list the access points again. So you can have a look at that code by yourself. It's fairly straightforward. There's a list networks function which does the list, executes the scan networks function, which is the bit that takes the delay or the period of time to actually do the scan and produce the list. And then once it's finished, it just steps through a loop and extracts the networks that have been found. Okay, so we'll look at a simple web server now. Again, in the Wi-Fi Nina directory, simple web server Wi-Fi. And once again, we'll just set the speed. Now there's a small bug in this, but first of all we need to set up our Wi-Fi access code. So most of these sample programs have a separate file here where you set your password and SSID for the Wi-Fi. So you can just type those in to these fields. Note that you have to keep the quotes. But there's also a small bug in this. So what you'll notice here is, where is it? So here, what this program does is based upon a web request, it'll turn the LED off or on. So here we can see it setting up pin 9 for output, which implies that's where the LED is meant to be connected, and indeed it says that here. But further in, if we look at the code, it's actually writing to LED built in, so that's not going to work. So I could either change this 9 here, wherever it is, to LED built in, or let us change this to 9, which I think I'll do because I've set up a small circuit with an LED and obviously current limiting resistor connected to pin number 9. So we use that. With that, I think we should be good to go. Just check the serial monitor, so upload that. Okay, so it's connected, hopefully. Oh, I mistyped the SSID. Okay, so there we've got our connection, and as the instructions state, we can see the page in action simply by browsing to that. So I'll just copy that, and that's our web page. So where that's coming from is this series of print statements here. So what happens is in the loop, it's waiting for a client to connect, that's our browser, then it's reading the data from the client as data comes in, and then if it's the first time through, then it's basically outputting this information. So you can see there's some header information which the browser just uses internally, it doesn't show, and then it says click here to turn the LED on, and click here to turn the LED off, and that's it. And then this next bit of the code, which we've sort of briefly looked at and modified, was if we see a /H or a /L, which is what comes from the URL, then it'll turn the LED on or off. So with a bit of luck, just re-establish these. If I click here, we should see our LED turn on, and there it goes. And then similarly, if I click here, it should turn off. So a simple little program. You can have a look at this yourself and see how to set up a simple web server. There are some other examples there that show how you can read a sensor. I think it reads an analog sensor and displays the value in a page. So there's a couple of examples that show you how to get data and display it in a browser like this. Next, I think I'll look at another way of returning data which is useful if you want to capture it or pass it to another program, and that'll be using MQTT. Okay, so we'll look at one more Wi-Fi example. and that's one that involves message queues. So the previous example looked at how to use a web browser to display some information or receive information and control something. MQTT is a different mechanism which is a little bit more suited to providing data to another program, whereas of course the web one is a bit more suited to displaying information that's human readable. Once again, it's in the examples, this case MQTT client, and so we'll use simple sender, and as before it has this little secrets file where we need to type in our credentials. So similar to before, this one attempts to connect to the Wi-Fi, and then it will periodically it'll send a message, hello, and then it's got this counter here. So the way MQTT works, or message queues work, is there is a broker or a server which has a topic which is defined, and that's set in this variable here, and it's initialized to Arduino simple. That's the name of the topic. And so what happens is people can send messages to that topic, and then the broker or the server will then relay that message to any client that's subscribing to it. So it's a little bit, I guess, like a radio or a TV station or a YouTube or something like that. Any number of people can submit videos into various topics, and people who are interested in that topic can subscribe to that topic and listen to it. So it's not a great analogy, but that's kind of how it works. Now this is using an online server. You can actually use a private broker, which the client software I'll use does give you the capability of, but we'll use the test one. And so what that means, other people could be also using this topic, and we may, in fact, will very likely see some other messages I've seen coming up, which is not from this program, but from other people that are submitting to it. So to receive it, I've started up this message prompt. So I've installed some MQ software called Mosquito. Mosquito provides a broker called test@mosquito.org, or it's test.mosquito.org is the URL. So basically what this command is doing is I'm going to subscribe, meaning I want to receive messages on the topic Arduino simple, which is what we defined here, and the host I'm going to use is test.mosquito.org, because that's where the messages I send, that hello and then the counter, are going to be sent to this broker or server. So I'll just hit enter there. We may see something come up straight away. Oh, there you go, there's already an A0, so we haven't even uploaded the program yet, but someone else is already sending stuff on this channel. So I'll invoke the upload, open the monitor, position everything so we can see what's going on. We're not seeing anything on the serial monitor because I forgot to set the speed. So I'll just quickly do that. Right, so we can see we've sent connection to the Wi-Fi, and now we're sending messages. And the reverse can also happen as well. You can also set up a receiver on the Arduino, and then you can use Mosquito Pub to send messages to the Arduino and get it to control things. Now this is just sort of sending a text message, but of course there's no reason why it can't send a number of data values, perhaps separated by commas or some other format of data, which makes it very much easier for a program to receive and process this. And client libraries exist for all sorts of programming languages, including Java and C and Python and processing, and you name it, there's going to be a library for which you can receive data. So this is a useful way for sharing data from Arduino to something else to do something with it. Okay, so we've looked at a publisher on Arduino. Let's quickly look at a subscriber for message queues. MQTT. Simple receive. So this basically does the same thing, except in this case we're going to receive messages. So if you had two Arduinos, for example, you could use this to send messages between them if that's what you wanted to do. I mean, there's obviously multiple ways you can do it, but that's one way you could use this. or in this case it might be that you're sending data to the Arduino to control some processors or something like that. Same as before, I have to set up the secrets. Actually, first I'll set the speed. Okay, so as you can see, the program is connected and it's waiting for some messages. Now previously we saw that A0, that may well pop up on here as well. If you wanted to have a private channel, you can change the topic, and obviously you could also set up your own internal broker, which is fairly straightforward. I just haven't bothered doing that because I don't want to open any ports on this computer to support that, but you could certainly do that as well. So this is the command that publishes a message. So again, anyone that's listening to this topic, Arduino Simple, on this server or this broker will receive this message. So it won't just be private to us. So just be aware of that if you're sending out information, you don't want to send anything sensitive. But we use Mosquito and then publish. So pretty much the same format. The topic is Arduino Simple. The host or the broker is test.mosquito.org, which is what we're connecting to here. The port 1883, which is actually the default. I don't think we need to specify that, but nevertheless. And then -M, which is the message. So in this case, I'm going to send hello Uno WiFi R3. So theoretically, I'll hit enter, and there it is. So I could send another message, test for example, and there it is. So that's a couple of sort of high-level protocols beyond just accessing the Wi-Fi. You can use Mosquito or MQ message queues, and also set up internet browsers. But you can also do lower-level sockets type communication. So basically, with the Wi-Fi, you can do anything that you like. You can send proprietary message formats on private channels or ports, or use more standard APIs such as web or HTML or message queues, or any other standard protocol for that matter. Okay, so switch gears a little bit and switch over to Bluetooth. First of all, we'll look at a scan. For some reason the Bluetooth examples are here. So central. So this is the scan. There's two examples there. One was a scan with a callback. The callback just, you start it and it constantly sort of gives you a message when there's a new client or a new node detected. This one just runs through a list and periodically just refreshes it and prints it out. So just upload it, change the speed as cross. Okay, so we can see it's discovered a few things. There's one there called a scale. There's a whole bunch of things that don't have names. There's this LE Inky, have no idea what that is. So that's the scan. If we just leave it, it'll keep reporting discovered devices, but I'll leave that for you to do. Let's move on and try something a little bit more interesting and see if we can control something. Okay, so let's take a look at controlling something on the Uno. So examples. Still can't quite get used to the fact that the Bluetooth examples are down here. So this time we want peripheral and LED, and what we'll do is we'll control an LED on the Uno. So once again, if you have two of these or another Bluetooth device, you could actually do this from another Arduino that controls this one. In this case, for simplicity, I'll just use a test program on a tablet. Set the speed so we can see our messages, and just quickly go through it. So what this is doing is it's creating a service, and this is a long hexadecimal string which we don't need to worry too much about, but we'll see it when we look connect to our device. And what it does is it turns on a LED or turns off an LED based upon input from our device. Now you can see that this is setting a name, in this case it's just simply LED, and we establish the service, then we advertise it, so that should allow us to see it in our Bluetooth program on our tablet. And then basically what it's doing is it's waiting for people to connect, and then depending on the value that's sent to it, it'll turn our LED on or off. And the way it works is if the value received is a 0, then it'll turn it off. Otherwise, if it's any other value, it'll turn the LED on. So as you can see, it's using LED pin, which is set to LED built in, and seeing as I have an LED connected up on pin 9, I'll change that to a 9, and I've already changed the speed. And so with that, that should be good enough. I'll upload that. Set the serial monitor. And also, so this program is one that I use to control it. This is Android, but you can get these programs for iOS as well. And you can see there's a whole bunch of service available. There's that LED Inky that we saw before. So I have no idea what that is. That must be another person's device. Oh, there it is, LED. That's the service that we created. And then the other thing that's of relevance is this number. So if I click on our LED, connect to it, so we can see someone's connected to us. That's this Android application, and then we have this custom service here. You can see it's got the same hex number, E8F2, 4F6C, more numbers, and then 1214, so that's the same one. So if I open this one up, you can see I can read and write from it, so I'll click on W to write to it. Let's put the Arduino up so you can see that. So right now the LED is off. So if I write to it, choose binary, and now you can put any number, like 42. And so that is non-zero, so it turns the LED on. If I now send it a 0 value, then it goes off. So as far as turning it on, any text will be non-zero, so I'll send it a letter K, for example, and that turns it on. You can't enter a binary 0 in the text, so you have to choose byte array and enter 00 to turn it off. And there it is. So you can use this to have devices control or interact with your Arduino, or you can do the reverse and have the Arduino interact with other devices. Now if I exit here, you should see that it disconnects. Okay, so thanks for watching. I hope that was interesting. I hope it was useful. I hope you got something out of it. I hope it might inspire you to try a few different things. If it was, let me know in the comments. If you'd like to see something in the future, also let me know in the comments. Also, if you can help me out, support me, go and check out my Patreon, or perhaps also buy me a coffee. It would also be very muchly appreciated. And you can also find me on social media, on Reddit and LinkedIn and Twitter and a few other locations as well. So see you out there, and see you next time. Thanks for watching.